Hi guys, welcome to today's video. We will be talking about init files, variables and expansions. So let's get to it. So printf and echo. That's a new one, right? Printf. But truly we use printf and echo to actually print out commands or print out outputs on our screen. So while echo is the commonly used one, printf actually means print formatted tests or just print something, just like echo. If you do in the C programming language, you will come across printf a lot. And this is what we have from the man page itself. It says printf formats and print arguments under control of the format. So let's clear this and let's put it to test. So let's try something with echo and let's see how it works with printf. So in echo, normally we will do something like this. Hello friend. And let's do this with printf. Hello friend. So you can see what has happened. You can see the very first difference. So echo actually brings it to a new line, while printf just prints it out and you still have your command on the same line. So this goes to show you that it's printing it the way you formatted it. So if we want to bring this to a new line, we have to add the new line character, and that is the /n, enter. So it shouldn't look like magic. So let's check the man page. So I have this man page pulled out for us already, and it shows us the different kind of escaping that we can do with the printf. So you see you have the backspace, you have the alert, you have the backslash, you have the double quotes, you have the new line. This is the one I just used, new line. You can also have carried return, horizontal line and vertical tab. So let's try horizontal tab and vertical tab. Same command, new line. So I'm just going to add /t and let's see. So as you can see, it's working like a typewriter now. So it's putting tab in front of what we just typed out. And that is why you see that our command, this place where we put in our command, has been pushed to the front because of the /t we had in front here. So that is what is applicable here. And what if we do the /v? And let's see what happens. So you can see now there's an horizontal tab and there is a vertical tab. So that is printf for you. Basically, like it told you, all it does is it helps you in printing out pre-formatted text on your screen. But also, like printf in the C programming language, we can also do some mathematical stuff, or let's say format specifying, using this. And let's see it in action. So what if we want to print out a quote? You can do something like this. Sorry, a float. So a float is a number that has decimal points. So we'll do something like this. Then the format specifier. Then we can say f. Then the number that we want to print as a float. So let's say 300. Okay, so that's wrong actually. So we need to put in, oh sorry, I used printf. You have to always know that it is printf, not just print, okay? Printf. So I just did print and I just turned this number 300 to a float. But let's clean this up. So to clean it up, let's put our new line here. Okay? And now we have it properly as 300.00. And we can also set the precision. And how do we set the precision? Precision is the number of decimal points that you want. So if I want 2 decimal points, I will just say in front of f, I will say 0.2. Okay? And there you have it, 2 decimal points. All right. So what if we also want to turn the number 300 to an hexadecimal? We can do the same thing by saying printf. And for hexadecimal, you use x. Then let's put our new line and 300. And this is the value of 300 as an hexadecimal number. Now, I'm not just pulling this from the sky. We have it all on the man page. So if we scroll down a little, let's check the print F3 of the man page. So there are different sections of it. As you can see, we have the formats, and this is where we are working from. You can see this is what we were trying to do, where we do the format specifying, and there are different types of format that we can use. You see, I just used the one for X, and you have the one for F. So you see that there are different formats that you can use in formatting your numbers. Okay, you can format numbers in different ways. By just checking the man page, you will get to see it all in action, and you can decide on which of which you would like to use or which of which you would like to work with. So let's say we want to convert something to an integer. So we have D or I. Let's try that out. So let's convert 300. Yeah, not 300. So let's make it a float. So let's say we want to convert a decimal pointed number to a decimal. Okay, so /. So let's say 45.000. So enter. I still use print again. I'm sorry, guys. So print F. So as you can see, it turned it to 45 from 45.00. Just ignore this error. Okay. So that's the point. You can use printf to format your strings and format your numbers. All right. So as against when you use echo, that just prints out what you want on your screen immediately. So the next thing we need to talk about now is variables. So variables in shell or bash or script or bash shell scripting, variables are storage location with a specific name. That is, you give a name to a container that you use to store something. So anywhere you store a value, it's a variable. And variable comes with some, styles of writing them. The first thing first is you want your variables to be in uppercase, and there should be no space before and after the equal sign. So let's create our first variable. So let's call this variable name. Okay, so all variable names should be in capital letter so that you can always distinguish them. Then equal to, there should be no space before and after. Then the variable you want to store. So let me store the variable precious as name. Then enter. Now, if we want to access this variable, we can simply do something like this. Echo, then name. You see? You can also bring it to life by doing something like echo, my name is So you call your variable, my name is Precious. So you see, you can actually use your variable in the echo after setting the variables. So take note again, your variable name should be in capital letter, and there should be no space in between before the equal to sign and the after equal to sign. So also, let me show you something. So what if we have something called a variable called sports? Okay, then for sports we have foot. So I will store this. Now let's say we want to print out something like football. So I will do something like echo I love. So we have sport already as foot. Then what if I now put ball in front? I mean, I want to print out football. You see, there's a problem because there's no variable called sport ball. So it prints only I love. So for us to be able to concatenate variables, we do something like this. Echo I love. So you put your $sign, then a curly brace. So you put your variable inside of it, okay? Then you can now put the ball at the back. And let's see what this prints out for us. So you see, it says I love football. From previously, we couldn't do it, but using the curly braces, we were able to access it and concatenate it with a new variable. So now, stay talking about variables. In Shell, you have what we call the environment environment variables or global variables and the local or user created variables. So let's assess these variables, okay? So the first variable we want to assess is the global variable, okay? Let's assess the global variable. To assess the global variable, you use a command called print env. Or let's do env first. Let's see if it brings out something for us. So you see, env prints your global variable, but you can use print env just to, get it properly. So let me clear, it does the same thing anyways. So print env is going to print out all the global variables that we have inside of this shell session. So if I press the enter key now, I'm going to get all the environmental variables. And as you can see, there are a lot of them. The first one is telling us about shell. We have WSL distro. These are variable names: shell, distro name, pwd, log name, home. Okay? So now that we've called all the global variables, we can actually access them, and it's very easy. All we say is to print out my name, we will do something like so. As you can see, I just said print env user, and it called my name out because that is what it is here. User, sorry, down here actually. User, you. So there should be a user somewhere. I can't find it. Anyways, so to print out the user, you say print env user, or let's do print env name because we could see name there. Print env. And as you can see, it's the same thing. So it goes into the variable, into the environment, and check for the variable name and prints out the value. And that is why you have my name there. So if we do print env pwd, let's see what it prints out for us. And as you can see, it prints out our present or current working directory. So let's clear this. So take notes. For you to print out your, what's it called? To print out the environmental variable, you use the command print env. Okay? So once again, to print the global variable or the environmental variable, you use print env. Okay, print env. So let's clear this. Now, to also print what is called the local variables, we use set. Okay, so this is set printing out all the local variables, but they're just so much. Okay, so I just scrolled so much. So we can use the less command to kind of itemize them properly. So less is going to help us to put them in a very easy way to navigate. So let me clear this. Okay, so let's say set less. This is how you check the local variables. And before we do that, let's set some local variables. So remember we have some before, but let me do a new one. Let me call this one, let me call it, so doing is equal to learning shell. So you will see why it is a local variable and why we can access it. So now that I've set that, let's check it. So to see all your local variables, you use the set command, then you can pipe it to less so that it's easy for you to navigate. So let's scroll. So we are using less to check this now, and these are variables that we currently have. So if we scroll down, can you see the one we created, doing learning shell? So this is a local variable because we set it and it's available for us during this shell process. So when we scroll, we can see other variables that we can access by name. This is name, okay? If we scroll, so this is user, this is UID, this is WSL distro. So let's check some of them. UID user term, okay? So UID user term. So for us to check the different variables from sets, we use echo. So to print user, you do this. And you have precious. What if we want to print the UID? Yes. You see that is the UID. What if we want to print the term? Okay. And what if we want to print the variable we just set previously? Echo doing. So you see, for you to access local variables, you use the $sign and you use less. And for you to access the global variable, you use print env and no need for the $sign. Okay? Now, there is something else we should talk about, and it's called alias. So alias is a way of renaming or giving names to your command. So let's assume, let me clear all this. Let's assume we want to do a lot of things, like we want to change command. I hope you know you can change command. So changing command means you can do something like cd. You can cd into a directory. So I think I have a directory called clearning. Then you use semicolon. Then I can come back to where I was before. Sorry. Then I can even add a third command by, let's say I want to open another file in vim test.txt. If you check this, you can see that I've changed 3 commands. Okay, separating them with semicolon. This is the second command, and this is the third command. The first one is go into C-learning folder. The second one is come back to the previous folder. The third one is open this file called vim test.txt. Now let's check and see if it will respond. So enter, and as you can see, it just responded. It has done everything, and we are now back to the last command, which is open this test.txt file inside of vim editor. So let me just exit of this. Let's check out our command. So if you see, it went into cd learning, it came back, and it went into vim test.txt. Now imagine that you would always want to do this. The best way for you to do is to give this command a name, like assign it to an alias. And how do we do that? We say alias. But before we do that, let's check if we have any alias currently on this computer. So alias, enter. And as you can see, we already have some alias. So if you say the first one, this ALX-A, the one that prints all the command with that prints everything, even the files that have dots, that are dotted files, okay? So you see, we have some alias that come naturally with bash. And this is egrep. We talked about this previously. So what if we want to create our own alias? We'll do something like this. Alias, okay? Alias. Then the name of the alias, let's call this mover, is equal to, then the commands that we want to give to the alias. So let's say the first command is cd. It should go into learning, cd into learning, and come back to the home directory and open the test.txt file for us. And there you have it. So if we press enter now, we would have created this alias. The alias has been created. And for us to see this alias, let's do alias again. And as you can see, we now have a new alias called mover. Okay? Mover alias. So let me clear our screen. Now for us to use that mover alias, all we need to do is just to call the alias name. And this is the alias name. We called it mover. And as you can see, it just did everything for us. So let me quit again. So alias, like this, all the alias. So alias is going to save you from typing so much. Instead, you can just put your commands inside of your alias. Okay? you can just put your command inside of your alias. So what if, you know, there's a lot you can do with alias. You can chain a lot of commands, all right? So you can use it to delete files, to cd and go out, or we could even create an alias called home. So instead of doing cd this every time, we'll have an alias that will take us home. So let's create that alias, and let's call this omi. Before you give an alias name, check if the name is available. So if I say type home, that broke. So my system just went off. So you said type, then you check, but I'm not going to do that because I don't know why it broke my system the last time. So let's create an alias that takes us home. So alias, I call this omi. Okay, so it should take us where? It should take us home. So enter. So let's check all the alias we currently have. So now you see we have homie, and let's create the former, let's bring back the former alias that we had. Okay, so because the system shut down, so I couldn't save what we had previously. So let's create the former alias, and we call that mover. So we said it should go into where? It should go into C learning previously, and when it goes into C learning, it should come back home. Then you should open the test.txt in the Vim editor, and that's all. So let's check all the aliases we have now. You see, so we have the new one we created called cd home, and we have another one called mover. So if we go into C learning, or let's create a folder, let's create one, mkdir, let's call this touchy. And if we cd into touchy, wrong command. So that's a wrong command. Let me fix this up. So let's cd into touchy, the new folder we created. And now we're inside touchy. So if we call the omi alias now, let's see where it takes us to. You see, it takes us back home. Now, the next thing I want us to talk about is expansions. So expansions basically is how you expand your commands, okay? So you enter something and the shell expands it to something else. So let's check out some simple expansions. So clear? So the first expansion we do, you know, we try it every time. So normally when you do something like echo precious, it does what you want, right? What if we do echo star? Confused, right? No, don't be. Because the star, like you know already, it tells, when you use this star, you're trying to say match any character in the file name. So it has gone in and it has matched all the character and it has brought all the characters we have. If we do LX, you see it's almost the same thing. So you see we have all this and it went in to bring all the file names for us. That is file expansion, because all we said was echo star. But instead of it to echo star, it did something else. It expanded into something else, something big entirely. That is command expansion. What if we do something like echo t dot star? You can guess it. You see, it went in and it brought in all the commands, all the file names that starts with T, because that's what we are saying. Anything that starts with T, bring it out. And what if we say echo star dot tst? Yes. So now it has gone in to bring all the files that have the .tst at their ending. So basically, that is what you see with expansion. What if we do something like this? So let it fetch us all the files with uppercase in the name. So it echoed hopper for us. So it's just for you to see that the expansion works differently depending on the kind of command that you feed into it. So when we try the next one, the other one, echo. You see the difference? So because there was nothing that matches it, it echoed the command for us. But now we say go into the folder and call all the files that have lowercase, and it went in. Instead of printing this, it went ahead to print all the files. So that is file expansion. And if you don't understand it, it may be very, very confusing. But basically, it's just telling you that some commands can do more than you tell them to do. And that takes us to the next expansion, arithmetic expansion. So we can do mathematical stuff on Shell. And the first one you want to try out is, basically we know all the signs already. So we have plus, we have minus, we have multiplication, we have exponents, we have division, and we have modulus. Okay? So let's try them all out. So the first one is we can do mathematical stuff by saying echo, then this expansion for arithmetic, the brackets. So we say 2 plus 2, and that gives us 4. Okay, we can do the same thing for multiplication. 4. We can do the same thing for division. So the idea is you can do mathematical stuff. And what if we put this inside of variables? Let's say we create a first variable called num1 is equal to 10, num2 equal to 20. So now we can use the variables for our mathematical expressions. So we can say num2 divided by num1. Oh, sorry. So we did not put the dollar sign. So num2 divided by num1. There you have it, 2. So you can change it around. We can turn this to times. So you see, we can do mathematical stuff in our shell or in our terminal using the echo command if we properly use our expansions. Okay, so we could do minus, and there you have it. So that's that on the arithmetic expansions. Now we also have the brace expansions. The brace expansions are like shortcuts. They make life very easy. So imagine we want to print something like front A back, you know, front A, front B, back. It's going to take us a lot of time to do all this. So we can just go in and do something like this. Echo front. So what you put in front is actually called your postscript, your preamble, and what you put at the back is called your postscript. So we put the curly brace and we can say A, B, let's use capital letter A, B, C, D, E, F. Close the curly braces and end it with this. So because of the curly brace, it is going to expand everything we have there. So let's check it. And as you can see, we have front A back, front B back, from C back, D back to F back. Okay? So what if we want to print out numbers? Let's say echo. So we say number. Let's say we want to print out from 1 to 20. Does it work? Expand. That did not expand. So that is because we have an issue with our postscript there. So let's try that with a smaller value. let's say 5, 7. There's something wrong with the command. So let's do that again. Number 1 to 5. Still did not respond. Okay, but then we could also do something like this. Echo Z A So sorry guys, I've gone on to be typing 3 dots instead of 2 dots. So we are supposed to use actually 2 dots. Okay, so there you have it. I was using 3 dots. Sometimes these things are very difficult to see. So what if you want to expand the alphabet from Z to A downward? There you have it. So you see the expansion saves you the stress of typing so many things. So we could be funky with this. We could do something like echo st. So we can have OO, IL, AI. Let's close that and put hell at the back. So you see we have different words. The first one is stool, we have steel, we have stall. Okay, so let's clear this now. And what we have next or last is the init files. So what are init files? Init files are files that run anytime you start a bash session. So they are called init files because any function that you have inside of this file will be called anytime that the script runs. So one of the init file, or the most popular one, is called .bashrc, and I believe you should have it. So let's check where mine is. Okay. So one of the most popular init file is the bashrc. So if we say ALX So I have a lot of files here, but this is the file I want you to see, the .bashrc file. That is the init file for this, my Ubuntu application. So let me clear this Linux distribution. So I want to open that file so that you see it. It's in the home folder in your home directory. So first you do cd tilde, then you go home, then you can now open it. I like to use Vim, so I say bash ROC. So as you can see, this is my bash ROC file, and it has a lot of functions and commands. So let me just scroll through so you can see them. Okay, so I'm at the bottom actually, so let me go up. So you can see there's a lot and lots of stuff inside of it that controls how my application functions or how it works. And while you are here, you can also actually put in your own function. So just to see it at work, let's say I want to create a function that I use to open a file that has some information that I have beforehand. So let's do something like insert. So I want to create a function for myself that will help me in creating files. So I say new file. So I open the brackets. Then what do I want? I want to do an if condition to check if the file that I want to create is already created. So if it is created already, I want a message, and the message should be, so if it is created, then echo that this file exists already. And if it does not exist, what should it do? Else, it should put the following inside of the file. So you know what I want to do already. I want to first put my shebang. So when I create the file, the shebang should be there already. Bash. Then remember redirection. So inside of the file, put that at the head. Okay. Then I want some other stuffs inside of that file. So the first one is, let's say I want a description. So I will say insert file description. Here. Remember redirection. So I don't want to clean what I have previously. I want to append. So that's why I use double. Then I want to also echo who created the file. So this file was created by, I want you to see that you can also use your variable here. So file created automatically by user. Okay. So I also want this to be redirected into the file just after the other command there. So now that I've done that, the next thing I want is, I want to open this file immediately in the Vim editor, which is my favorite editor. So now that I'm done with that, I can now close this. So I say Fi, then I can close the curly brace now. So you see what I've done is, inside of my bash roc file, I just created a new function called new file that I will be using to create new files. And the new file I want to create should always contain the shebang. And after the shebang, it should contain the description that is telling me to put the description of the file. And after that, it should tell me how the file was created and by who user, by which person. And also, it should open the file immediately in the Vim editor. So let's try this out so that you can see what init files really do. So init means initialization. They initialize and they work immediately. You start your process. So let me save this. So we are back here. So because we are in a session already, for me to make that file, the new function work, I can do something like source bash roc. So this is going to reinitialize the bash roc file. Okay. If not, my function would not work. Okay. And if that hangs your computer, you can just close and reopen it. So I will just reopen the Ubuntu to repeat that. So now that I've reopened it, the new function I created will now be available. So let's try it. So I will say new file, then let me call this precious file. Okay. So remember what our function does. Create the file. After creating the file, put some stuff inside of the file. You put shebang, then put description, then it will also put who created the file, then it will open it in Vim editor. So let's see. And as you can see, it has worked. So it has put the shebang, it has insert the file description. It's saying insert file, so I can edit this, and it has told me who created this file. So let me exit. So remember the function, we said, what if we try it with a file that we've created already? What should it do? It should tell us that the file exists already. And as you can see, it says this file exists already. So that is init file working. That is how you create an initialization file if you don't have it. So if you don't have that file, you can do touch bash roc, it will create it, but I have it. And when you have it, you can open it and check what you have, and you can add more functions to it. So guys, that is it on init files, and we've been able to touch on variables, printf, set, alias. We've been able to touch on expansion and printf and echo. So guys, thank you, and I'll see you in the next one.